Coming back to this step, we identified it's a rational equation. You identified, you move the term or you don't. I highly recommend it, but it's up to you. And you said, I'm multiplying by x squared minus 3x or whatever you decided. Be very careful because you completely have to factor everything before you do so. Be careful how you simplify. If you don't state restrictions, you will say possibly, I'm not saying for sure, but you may say, oh, I got 0 and 3, done. But if you state the restrictions as I recommended, you will always go back and check. I stated the restrictions. Well, now I have to go back and check. You could also say, I don't care for these restrictions unless I'm asked to in a problem. But I promise that I will go back with whatever solutions I get, prospect solutions, and check. But that's more work, potentially more work. State the restrictions because this is a method that will be used for finding domains of functions. So this is extremely useful. Okay, our next step, where am I? Any questions on this problem? Do we need other equations or we move on to graphing some functions?
I've got a real quick question.
Yes.
Oh, I'm sorry. Oh.
Maybe you first.
Sorry, no, you're good. So for each equation like this, will they always have a restriction?
Perfect question. Only certain types of functions have restrictions. I am going to list a few. One that we already seen, rational. Now, if I have, let's say, 1 over x squared plus 1, x squared plus 1 will never be 0, no matter what you do. So it happens that this is a counterexample. This is a rational function, but it does not have restrictions because its denominator can never be 0. A second type of function that has restrictions is square root. Or any even index root. So the square root, the 4th root, the 6th root, all of them have restrictions. So if it's an even index, 2, 4, 6, they all have restrictions. What restrictions? So here, let me also add denominator not equal to 0. Here the problem is, and what about the other indices? What about the odd indices? So let's say Nabitha. What do you think about the other indices? What about if the index is odd? Are there restrictions?
So, I'm not sure.
Okay.
Would be.
Okay. No restrictions. No restrictions. This, an odd root, a cube root, the 5th root will exist from everything. I will always have an answer. The cube root of 8 is 2. The cube root of 0 is 0. The cube root of negative 8 is negative 2. This is friendly. Friendly. I don't have to worry about it. Like polynomials. I don't have to worry about polynomials. They're defined everywhere. But the even root is restricted. It cannot have negative under the square root or negative under any even root. Another function with restrictions, number 3, logarithmic. It can be any log in any base. It can be natural log. It can be common log. This is common log. and this is natural log. All of these functions or any other base have to be defined only on positive numbers. So you will not be able to determine natural log of 0 or natural log of -3. Thank you for the question. And there are others, of course. Number 4, trig functions. Like tangent, like cotangent, like secant, cosecant. So these are a few of the functions with restrictions. So if I encounter a log equation, I have to state restrictions. If I encounter a trig equation, and we have a few at the very end of this document, so we're going to look at that. Then I have to state restrictions. If I encounter a square root or any root other than odd, I have to state restrictions or be aware of the fact that I have to go back and check. Very good question. Who asked that? Very good. No one? Okay, I just dreamt about it then.
Sorry, no, that was me, Lindsay.
Lindsay, very good. Excellent question. Good. And by the way, what was I doing? Anything else here, or we move on to graphing?
Can we go over 3D?
The inequality?
Please.
Very good. So the inequality is 3 minus 7x less than 3x plus 6. This is not an equation. This is an inequality. And what are we going to do first? Let's say Killen.
I think you set them both equal to 0.
This is it's a linear inequality.
We want to the same side.
So we separate the terms. This term is moved to the other side, it becomes negative. Of course, x. This term is moved to the other side, it becomes negative. Okay, Gabriel, what do we do next? Say that again. I'm so sorry, I couldn't hear you.
I don't know. I'm sorry.
That's okay. But you will know next time, right? Because you will review this. That's all I care about. We have to divide both sides by -10. Can anyone give us the answer to this? Oscar. I'm sorry. Go ahead.
Maddie.
Yes.
X is greater than -3/10.
So you have x on the side, right? You have -3/10 to the other side. And what happens next?
The inequality sign flips.
So the inequality will?
Flip.
Yes. So when we divide, division, multiplication, of an inequality by a negative number, switches the inequality symbol. Please remember that in case you forgot. Now I would like to present this in interval notation. Okay. Tamara, interval notation.
Okay, so let's see. So if x is greater than
Excellent. So far, excellent.
Okay. So if x is greater than -3/10, then we would say we would do the hard bracket. I forgot the formal name of it.
It's called yes, it's called the It's either parentheses or brackets, but because there is no equal symbol, I must use the parenthesis, not the
okay.
bracket.
Got it.
The
Okay, great,
equal
thanks.
symbol will change into a bracket.
Okay, perfect. So it would be -3/10, comma, infinity.
Great job. Well
And then
done.
close bracket.
Great job. Okay, anything else, or we move on to graphs? Okay, let's move on to graphs.
Could we review the absolute one down below?
This one?
Yes, please.
Of course,
The
this is a
D.
graph. Let's start with D. Excellent. Well done. So we have a function, which is the absolute value of x minus 3 and minus 2. Perfect. So I would have mentioned before, when Lindsay asked, give me functions, or when do I state restrictions? I would have mentioned the absolute value here. I did not, because absolute value is friendly, unless it's in the denominator. So I have a combo. That's a different story. So this is a combination of two functions, and we're going to talk about it in class. It's function composition, inner function, outer function, not yet. So this is a rational function, but combined with an absolute value function. That's a different story. But here, we don't have x minus 3 in the denominator, so there are no restrictions. Domain, -infinity to infinity. Okay, so we create a table. The domain is anything. And I will, Josh, give me some values for x.
Multiple values?
Just x values. No, not too big. Let's,
So 1,
yeah, let's start with a negative. Let's say,
-2,
okay,
-5,
okay,
0,
very good.
1, and 6.
Okay, and definitely 3. I want to see 3 as well, and 6. Perfect. Perfect. Okay, so Oscar, can you give us the y values?
Okay. For the first one, it's going to be.
Yes, exactly. 8 minus 2. Very good. 6. Perfect. India, will you give us the answer for -2?
Five minus 2, which is 3.
So this will be -2 minus 3, which is -5. The absolute value will be 5 minus 2 is 3. Very good. 0, obviously you got the picture, so it's 3 minus 2. With 1, I have -2 minus, in absolute value is 2. 2 minus 2 will be 0. With 3, I have 0 minus 2, -2, and 6 minus 3, 3 minus 2, which is 1. We're ready to graph. Perfect. Before we graph, I just want to make one more note here to remind you of absolute value function is also called a V function. So please keep that in mind. Every time you talk about the absolute value function, it's a V function. Okay, so now I have the ordered pairs. I'm going to plot from left to right. And Kush, give us the first ordered pair. -5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Next point then.
-2 Plus 2, 3.
Minus 2, comma 3. It's an ordered pair, negative 2, comma 3. So negative 2, comma 3 will be this point. And then 0 and 1. Any questions?
1 and 0.
Okay, 1 and 0, very good. Right here. 2, 3, 4, 5, 6. So 3,
Minus 3.
3, comma negative 2,
2, 1, 2.
and 6, comma 1,
1 and
right here, and so on and so forth. Now, I have to be careful and make sure that this is the last point and it doesn't go any further, right? So I do know from transformations, if you remember transformations, so the v function absolute value of x, absolute value of x looks like this. This is the absolute value of x. It has this corner, if you want, at 0. It bisects the second quadrant and the first quadrant. So what happens here? This is a transformation that moves this graph 3 to the right. So I will have something like this. This is the graph of x minus 3 in absolute value. And now this graph is pulled down 2. So now I know that at x equals 3 is pulled down 2. So this is indeed the correct point, which is the corner. So obviously we'll cross here. Now I'm ready to graph. It's a v function. I also want to show you, do I have another minute? I do have another minute, but let me